Okay, first a clarification for this problem. When you have something like this, which is really interpreted like this n plus 1 is a subscript. So we don't say to the nth, we say sub n plus 1. So this is a sub n plus 1. Here's what we're given. We're given that we have a series which each term, a sub n, is greater than 0 for all n. And then we're told this. Oh, this is supposed to be an n here. The limit as n approaches infinity of a sub n plus 1 over a sub n is 3. This is an example of using the ratio test. When you have a sequence like this, and you can take the limit as n approaches infinity of the next term divided by the previous term. If that limit is less than 1, the series is absolutely convergent and hence convergent. If L is greater than 1, the series is divergent. So this series is clearly divergent because of this limit of 3, which was given. Now if we go to board 2, here I've rewritten problems 1, 2, 3, and 4 as to what they represent. This is problem number 1, problem number 2, problem number 3, and problem number 4. And what we're going to do is apply the ratio test. So we've already seen that this one is divergent. That's given because this number is greater than 1. Now, here's the ratio test setup for problem number 2. What is that actual limit? Well, if I rewrite this, I'm going to drop the absolute value symbols. A sub n plus 1 over a sub n times n to the 5th over, now if you picture expanding this, you're going to get n to the 5th plus 5n to the 4th and so on. But the idea is that if you take the limit of this as n approaches infinity, we know that this is a 3, that first fraction, and this is a 1 because of n to the 5th over n to the 5th. Polynomial function, a rational function where the degree of the numerator equals the degree of the denominator. We look at the coefficients of those highest degree terms. That's a 1. Therefore, this series is divergent because that limit L is greater than 1. And now we'll go to the next board for these last two. Here's the setup for the ratio test. What does this simplify to? I'm going to not write the limit. We'll do that later. But again, if I write this as a sub n plus 1 over a sub n times 5 to the n over 5 to the n plus 1, this becomes a sub n plus 1 over a sub n times, well, if we subtract exponents, we get 1 over 5. And so this is 3 times 1/5, 3/5, which is less than 1. Therefore, this series converges. And finally, if I do the same thing here, I get a sub n plus 1 over a sub n, the quantity squared, times, same deal, 5 to the nth over 5 to the n plus 1. We know that this expression in here, if we take the limit as n approaches infinity, is 3. But we've got this exponent of 2 here squared, and this is still 1/5. But now we've got 9/5, which is greater than 1, therefore divergent. Okay, so this series, based on the given information, is the one that converges. There you go. Hope that helped. If you have any questions, post a comment.